So under exercise 2.2, this is E and F. Here the point E and F are on the sides of PQ and PR respectively of triangle PQR. For each of the following cases, state whether EF is parallel to QR. Right. So in the given statement, we don't have any yes, we don't have any triangle, we don't have any figure. So here according to statement we have to draw the figure. So here let me start writing the figure. So here E and F, so the midpoint of yes, E and F are on the sides of PQ and PR respectively, are on the sides of PQ and PR respectively. That means E is the midpoint of PQ and F is the midpoint of PR respectively of a triangle PQR. For each of the following cases, state whether EF is parallel to QR. We need to prove. So EF is parallel to QR, right? So according to first problem, so here see PE is equals to 3.9 centimeter and EQ is equals to 3 centimeter. PF is equals to 3.6 centimeter and then FR is 2.4 centimeter. Right, children? So we know that according to basic proportionality theorem states that if a straight line is drawn parallel to side of a triangle, then it divides into other two sides proportionally, right? If a straight line, here EF be the straight line, EF is drawn parallel to side of a triangle, that is QR. EF is parallel to QR, then EF is divides other two sides, that is PQ and PR, which is divides other two sides are proportionally. So that means in triangle PQR, so EF is parallel to QR. According to basic proportionality theorem states that PE by EQ, which is equals to PF by FR. So here we know that by substituting the given values, PF is 3.9, EQ is 3, which is equals to PF is 3.6 and FR is 2.4 centimeters. So here see, by taking cross multiplication we get see 3.9 into 2.4, which is equals 3.6 into 3. So when we multiply these two, 3.9 into 2.4 we get 9.6 and 3.6 into 3 we get 10.8. So here 9.6 is not parallel to 10.8. So EF is not parallel to QR. EF is not parallel to QR, right? So hence the given values, so the given according to by solving this we get so EF is not parallel to QR, right? Again I am going to take a second sum, that is see where E and F are on the sides of P and PQ and PR respectively. That means E be the midpoint of PQ and F be the midpoint of PR. EF is the straight line. So the given straight line EF is parallel to QR. EF is parallel to QR, right? So E and F are on the sides PQ and PR respectively of triangle PQR. For each of the following cases, the second case is, see, this is the second sum. This is the second example, the second sum. So here PE is equals to 4 centimeter, QE is equals to 4.5 centimeter, and PF is equals to 8 centimeter. And RF is equals to 9 centimeter. So this is the required figure. So that is PQR is a straight line. E be the midpoint of PQ and F be the midpoint of PR. So here EF straight line, the straight line EF is parallel to QR. We need to show that, check whether the straight line EF is parallel to QR or not. So on substituting the given values in the figure, so this is PE is equals to 4 centimeter, EQ is equals to 4.5 centimeter. There is no change of EQ and EQE. both are same only. So next we have PF is 8 centimeter and RF is 9 centimeter by basic proportionality theorem, according to basic proportionality theorem. So as you all know that by the that is basic proportionality theorem states that if a straight line is drawn parallel to side of a triangle, then it divides into other two sides proportional, proportionally. So that is PE is equals PE by EQ, which is equals to PF by FR. PE divides by EQ, which is equals to PF by FR. So according to basic proportionality theorem, PE by EQ, which is equals to PF by FR. So we need to check the given statement is right or wrong. Check whether the following values is follows that EF is parallel to QR or not, right? So here I am going to consider, so this is PE by EQ, so the value of PE is 4 centimeter and the value of EQ is 4.5 centimeter. So 4.5 by 4, PE is 4 and EQ is 4.5 and PF is 8 and FR is 9. On substituting the given values in the given basic proportionality theorem, so we get see here 4 by 4.5, it is already in the simplest form. So here see 4 to, so see here I am going to divide this divide by 2 and divide by 2. So here 2 1s are 2 4s are 2 4s are 8. So 2 divides by 8 divides by 2, 2 4s are, that is 4. So 9 all half. So here, so 2 4s are 8, 2 5s are 10. So that is 9 by 2 is nothing but 4.5. So here 4 by 4.5 and 4, which is equals to 4 by 4.5. Hence we get LHS equals RHS. LHS equals RHS. Hence PE is divided by EQ and PF is divided by FR. So therefore EF is parallel to QR. So therefore EF is parallel to QR. So here, so the given EF is parallel to QR, hence the given triangle ABC. So by according to basic proportionality theorem, if a straight line is drawn parallel to side of a triangle, then it divides into other two sides are proportionally is verified. Hence we get PE by EQ, which is equals to PF by FR. So therefore EF is parallel to QR. Next we have under 2.3 in the same question. So E and F are on the sides of PQ and PR respectively of a triangle PQR. For each of the following cases, state whether EF is parallel to QR. So next we have third question under this third example. So that is see, PQ is equals to 1.28 centimeter and PR is equals to 2.56 centimeter and PE is equals to 0.18 0.18 centimeter and PF is equals to 0.36 centimeter. So this is according on substituting the given values in the required triangle PQR. Here EF is a parallel to QR. So by substituting we get PQ. The overall the length of PQ is 1.8 under this P where PE is 0.18 centimeter, 0.18 centimeter, and so the value of the side of a length of a side PR is 2.56, hence PF is 0.36. So here, so in the previous only we are discussing about Corollary 1 and Corollary 2 under basic proportionality theorem, Corollary 1 and Corollary 2. So this is, see, this is a basic proportionality theorem. Here DE is parallel to BC, where yes, if straight line is parallel to side of a triangle, then it divides into other two sides are proportionally. That is AD by BD and AE by EC. AD by BD and AE by EC. This is known as the basic proportionality theorems. basic proportionality theorem. And then corollary 1, so this is corollary 1, so that is AD by AB, AD by AB and AE by EC. So that is corollary 1. BD by AB and EC by AC, that is corollary 2. So by substituting corollary 1 we get AD by AB divided by AE by EC according to corollary 1. According to corollary 1, so we have, see, by doing corollary, by applying by corollary, yes, by corollary 1 we get see PE by PQ, PE by PQ. According to the given data we can take a corollary 1, so that is PE by PQ, which is equals to, where PE is 0.18 divided by 1.28. So when we multiply after decimal we have two digits, we have two decimal places are there, so we can multiply 100 on both numerator and denominator, we get 0.18 into 100, we get 18, 1.28 into 100 we get 128. So by simplification, this is 2 9s are 18, 2 6s are 2 4s are, so the standard the simplest form of PE by PQ is 9 by 64. And hence I am going to take another site, that is by using corollary 1, that is PF by PR, PF by PR, where PF by PR, where PF is 0.36 and PR is 2.56. Again we have, after the decimal point we have two decimal places are there, so when we multiply 100 on both numerator and denominator, we get 0.36 into 100, we get 36, we get 36, and 2.56 into 100 we get 256. So when we multiply, see, this is 4 9s divide by 4 on both numerator and denominator, so this is 4 9s 36, so this is 4 4 6 24, remaining one 4 4 16. Hence the simplest form of this 36 by 256 is 9 by 64. Hence we get PE by PQ, which is equals to PF by PR. By using corollary 1 we get PE by PQ, which is equals to PF by PR. Therefore EF is parallel to PR, therefore EF is parallel to QR, EF is parallel to QR. Yes, very good pa. Then